This assessment asks us to examine this chemical equation as a way of telling why sulfuric acid, a strong acid, is at once an Arrhenius acid, a Bronsted-Lowry acid, and a Lewis acid. To start with the Arrhenius acid, an Arrhenius acid is something that increases the concentration of H3O+ in solution. And so what we see, sulfuric acid, upon reacting with water, has in fact created more H3O+. It's an Arrhenius acid. Sulfuric acid, if we look at what's happening as we go from sulfuric acid to the conjugate base here, the sulfuric acid has lost a proton. A proton has been lost. The Bronsted-Lowry definition of an acid is that of a proton donor. Sulfuric acid is a Bronsted-Lowry acid because it has donated a proton. The last one is the Lewis acid definition. In this case, the sulfuric acid, by the way that it donates that proton, is the oxygen lone pair right here actually will grab that proton. Those electrons will be donated to that proton. In that way, the last electron, so we'll go ahead and kind of preview future chemistry. That bond will now move on to oxygen. In this way, sulfuric acid is an electron pair acceptor. This proton is accepting an electron pair from that oxygen. It is a Lewis acid.